All right, finally. You know, I'm excited to do this. I've been really wanting to get into this for a while because this is a lost art, and it's called the ball dimension. And I'm going to tell you right now, and I mean this with all due respect to the guys I work with, it's just not their fault. Very few people know how to do this anymore. And in fact, I was given a drawing just yesterday by the plant manager and asked me to calculate a ball dimension. That means, you know, out of a shop of 150 guys and an engineering staff, they trust me to do this, and I love doing it. And nobody teaches people how to do this, so they trust my math. Now, what is a ball dimension for? And this is an intro tonight, and let's talk about that. Well, I've got this block that we originally started this whole series with, this block here, and these guys they want a 10-degree angle here, and they want it 1 inch down, and there's a couple things we need to do. How do we know this angle's right? Remember, first of all, I taught you we're going to check it by on a sign plate or whatever, and make sure, not on whatever, a sign plate or some sort of gauge, and make sure our angle is 10 degrees. Okay, that's the first part, and I remember explaining that to you earlier. Because if the angle's wrong, the ball dimension is going to come out wrong. So first thing we need to do is make sure whatever we're doing with this, a grinder, a mill, a 10-degree cutter, that we've actually established the correct angle, or the ball dimension won't come out right. So what's the purpose of a ball dimension? Well, here's what you need to know here. How are you going to measure from here to here? Because they want this 1 inch. Now, I know what you're saying. Well, I could put it on a comparator, and yes, you could. But this edge better be dead sharp. Because if you deburr that at all around that edge, you can't find the sharp corner, okay? So that takes away the comparator a little bit, because you don't have a sharp corner left. Because to check this angle correctly on a comparator, everything's got to be dead sharp. As soon as you start filing off edges, just a little bit with a hand grinder or something, you've lost that ability, okay? Now, the next way, if this doesn't matter, if this was a chamfer for weld, you could scale this, you could put a pair of Verniers on it and see. You know, that's about what it is. So here's what you got to do. So first thing, if I were doing this, you have to know a few things here. They want this 10-degree angle held here, and to do a ball dimension correctly, you got to know what's the thickness. Because what we really want to know here, eventually, is this is going to be the dimension we need to know. When I'm all done, and I check this, what's it supposed to be? So that's very simple. Let's go back to our first lesson. So first thing we do need to know, of course, though, is the thickness of this part. So let's just call this a 1 inch thick part, okay? That's what it looks like on the print here. So 1 inch thick part, what's left here? Well, we know here's our triangle, right, guys? We know we've got an adjacent side, and we know we have a tangent or a 10-degree angle. So that's the simple formula to drop in an angle. Remember that lesson. So 10 tangent, and of course I'm going to multiply it by 1 inch, but it doesn't matter because it's the same thing. The drop in the angle is 0.176. So if I hit my plus to minus key, that makes it a negative number. Plus 1 inch equals this distance right here. This is what we got to know. 8, 2, 3, 6, 7. How are we going to check that? How are we going to do that? And again, comparator, yeah, as long as you don't roll this edge over. But there's another way to do it. And you can't put a pair of mics over this, because your mics have a thickness to them, right? They have an anvil. And depending on where your anvil hits, you know, you're not going to get right to that edge. You just can't do it. And again, it depends on your tolerance. But anything closer than plus or minus 10 thousandths, you need a ball dimension, okay? So let's take the same part now, and I'll redraw it, and we're going to learn how to do a ball dimension. So back to redrawn the part. We now know this dimension here using our simple trig formula, 0.8236. And we know this is a 10-degree angle, and we've checked it with a dial indicator on a sign plate or whatever, and we know now that this is 10 degrees. Got to be 10 degrees, and you'll understand why. I told you already why you can't check it like this with a pair of mics or verniers, because you just can't get your mics right to that tip. So what we do in that case is we establish a plane here, whether you put a magnet here and a ball bearing, but you put a ball in here. And there's your ball dimension. And what we need to know is the distance from here to here. Okay? That's how you check an angle correctly. Makes sense? It really, really should. Now, if your part's small, you can put, like I said, put a little magnet on there and drop a ball bearing in there as long as you know the diameter. You got to know the diameter of the ball. Should be nominal, 1/2 inch, 3/8. You can do whatever you want, but nominal thing. So here's the deal. I'm going to show you these. Not too many people get to see these. This is my personal set of ball dimension rolls I've made over the years, and different sizes, and they're mounted to a plate. And I can put this plate up against something, and then I have something to mic over. And I can loosen this bolt and move the plate around. This is a 1/4 inch plate, a little piece of this is like 3/16 steel that I took the time many years ago. It looks like about an 832 punched in there. This is a bigger one. This is a 1 inch one, 1/2 inch. I use this one a lot. Okay, so this is my set. And depending on the size of your piece or what you're doing, you can see this one's actually set at a little bit of an angle here because I just loosened it so I had more room for my mics. I've had these for 30 years, okay, and they work really, really well. And there's my old trig book too. Great. So, couple different things. These are great. These are very inexpensive. This is basically a 01 gauge stock. You buy a bar of it or cut off or something, and it looks like this one's about 3/8 of an inch thick. All you do is, this was a drill rod, because drill rod's got a little case hardened on the outside, but you can drill and tap it. So I've got these up to 2 inches, and I'll go through a lot more of this as we go through the series. But tonight is just an intro. So basically what we want to do is find out the distance from here to here. And there's a way to calculate, remember, and that's why I was teaching you guys about your triangles. There's 2 triangles right there you need to calculate. Well, actually 1, and then the one you need to know is this. Okay, now I'm not going to teach you how to do that in this lesson. Don't be mad. I'll teach you, but because I'm going to give you the easy way out. This is the chart I'm going to put up tonight. This is a chart on how to find your values for all these angles: 1/2 degree, 1 degree, all the way through 30. It's 1 degree increments through 10, 11, 12. Then it jumped to 15, 20, 20. I hand printed this years ago. No mistakes. I came in 1981, so 32 years ago. I did this chart, and it's very accurate. And there's 2 different dimensions you need to know, either A or B. So in this case, we were doing the B dimension. And if I flip this around, you can kind of see it. I just want to make sure of that. B. Well, we'll just do it. So basically, if we know this is 8.236 and this is 10 degrees, all I do is go down to 10 degrees, and what's the size of the ball I'm using? 1/2 inch. The B dimension is 0.5479. Then just add half the ball, which is 0.250. And now you know it's 8.8236 plus the ball dimension, 0.5479, plus half the ball. Boom, 250. Okay? Add those 3 numbers together. 0.8236 plus 0.5479 plus 0.250. 1.621.5. And that's what you should measure across there. Now, that's just quick, but this was an intro, and we're going to really get into this. Now, you might say, well, I don't need any more lessons, Phil. You just explained it to me, and you got this great chart. Yeah, well, what are you going to do when you get an angle like 8.218 degrees? You got to know how to calculate these. Okay, these are just for nominal dimensions, or the degrees. So I'm going to put this up there, download this, and as the week goes by, I'm going to do more of this for you. But this was an intro to a ball dimension just to show you why it's more accurate. Okay, you're miking across this ball will definitely hit a spot here. You need to know where that spot. We calculate it back. That's how you check an angle. And once you learn this, you are the man. Okay, this is, like I said, 150 guys. I'm the only one in the shop that can do it. So I'm Phil Kern, the Tool and Die Guy. Welcome to Ball Dimensions, and like I said, a lot more to come. See you on the next video.